Hi there, my name is Yuri Polyanetsa, and today we're talking about databases. We live in modern time and we are surrounded by data streams, starting from your favorite smartphone and up to some, IoT devices. Your grandma's smart needle, for example. Where all of this huge amount of petabytes gone out? It's one of the most important challenges humankind faced with. Obviously we, I mean us full stack developers, it's joke of course. We store our nest eggs in toilet tanks and sometimes in databases. Are you interested? Let's get our hands dirty. As you know, there are two approaches to store some data, so-called SQL-based and NoSQL-based. Generally, each project is managed by database management system. Then it's necessary to choose a database management system. The main question usually consists in choosing a relational SQL or non-relational NoSQL structure. So, imagine a city, for example. Let's it be called City A, where everyone speaks the same language. All businesses is conducted on it. It's used in any form of communication in general. This is the only means of interaction and understanding for the inhabitants of that city. Changing the language in any of areas of activity will be confused for everyone. Now imagine city B, where all the inhabitants speak different languages. They interact in a completely different way with the world around them, and for them there is no universal means of communication. Relational databases use so-called structured query language syntax (SQL) to define and process data. On the one hand, this opens up great opportunities for development. SQL is one of the most flexible and widely spread query language, so its choice minimizes a number of risks and will be especially useful if you have to work with complex queries. It's very important. SQL, on the other hand, had a number of limitations too. Building queries in this language require to predetermine the data structure and, as in the case of the city A, subsequent changes in the data structure can be damage the entire system. Non-relational databases instead offer a dynamic data structure that can be stored in several ways. Column-oriented, document-oriented, in the form of graphs or based on key-value pairs. Such flexibility means the following. You can create document without specifying their structure in advance. Each document may have its own structure. Each database can have its own syntax as well. You can add fields directly while working with data. In most cases, SQL databases are vertically scalable. That means you can increase the load of a single server, increasing the power of central processors, RAM, or storage. And NoSQL databases are horizontally scalable. This means that you can increase traffic by distributing it or adding more servers to your database management systems. It's the same as adding more floors to your building or adding more buildings to the street. In the second case, the system can become much larger and more powerful, making the choice of NoSQL databases preferred for large and ever-changing data structures. In relational database management system, data is presented in the form of tables, while in non-relational in the form of documents, key values pairs, graphs, or wide column storage, and other. This takes SQL databases the base choice for application what involve transactions with multiple records, such as an account system, for example, or for legacy systems what were built for relational structures. Database engines for SQL databases include MySQL, its most important drive, Oracle, PostgreSQL, and Microsoft SQL Server. And for working with NoSQL, MongoDB, its most important drive, Bigtable, Redis, RavenDB, Cassandra, HBase, Neo4j, and CouchDB are suitable. So, which database management system to choose? MySQL is the right choice for any project that can rely on predefined structure and defined schemas. On the other hand, MongoDB is a great option for fast-growing projects without a specific data schema. In particular, if you cannot determine the schema of your database, none of the other database management system offered by you is suitable for you, or it is constantly changing in your project, as for example in the case of mobile application, real-time analytics system, or content management. Let's practice. We are common people and there is no choice for us, unfortunately. As you know, there is widely spread, most famous and most commonly used software package, Microsoft Office, all rights reserved. Consists of MS Word, MS Excel, MS PowerPoint, and more. And of course, MS Access we can use for. It's some kind of user-friendly database management system with a nice interface and a powerful SQL drive behind it. And there are some alternatives like LibreOffice, OpenOffice we can talking about today. Unlike commercial one, this product is Apache licensed and completely royalty-free for your personal usage and of course for educational purposes too. As a result, they are not fully compatible and the last one have no some sweetie features. Let's go. If you choose OpenOffice, you can navigate to the official OpenOffice web page in the section of download and select your installer depending on your operational system. Select your language, select version. I don't recommend you use some minor previous version. You can use last one. You can as well download some language pack and follow this link and download and install your package. Install your OpenOffice into your personal computer. That process is very simple. You can just click next, 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 next step, accept license agreement and click finish. Then you run your OpenOffice main icon. You can see a main window and Microsoft Office alternatives present here. It's very similar to the MS Office, but have some difference. It's not fully compatible. As you can see, you can create documents, spreadsheets, presentation, and database. Run your database tool and check its interface. You can see database wizard what can guide you through database creation process completely step by step. So first of all, we can use checkbox to create or open existing database. In our case, we wanna create a new one and click next. So next move, we have to make a choice. We want to register our database or not. If you want to distribute your database easily, for example, send it into email, uh, you don't need to register your database. And we can use checkbox to open database for editing now. And click finish. Next step, you can specify your paths, your full paths, where you wanna store your database. For example, we can navigate for this path and make a title with extension ODB. For example, patient. And click save. As a result, Base, OpenOffice Base main window will be appeared. OpenOffice interface is very user-friendly and very convenient. You can see main menu, quick toolbar, and most commonly used tools. As you know, we most commonly used tables creation, query creation, forms creation, report creation. And we can see tasks we can apply depending of quick tool you choose. For example, if we want to create a table, we can use one of these, and quick description will be appearing depending on our mouse cursor hovers. This field contains our created results, and this part of window can consist quick preview depending on your quick tool applied. Let's create some interesting and something close to the real world. We can follow this guide and create some database named as patient, would consist of two tables, main one and second order one. Our main table can consist some information about our patient, and each record of this table can represent each patient as well. And we can attach some sub-table what consist of some patient record depending on the blood test. Main table can have a title as passport, and minor table can have a title as test blood. In general, as you know, the term of relational database can be explained as some kind of graph where each nodes can be represented as a tables, and Each interconnections can be represented as a relationship between Z tables. And as you know, we can we can attach one or few tables one between other. In another word, we can make relation one to many, many to one as well, and make relationship between Z tables. In this case, if new patient visit our clinic, new records with ID person will be created and appended to the table passport. Each time any patient pass blood test, new records with ID test with auto-counted up ID test will be appended to the table test blood. And as you know, each SQL table consists of tables with one single level of nestification. In another word, it's a plain table with columns and rows, where each column represent each separated variables, for example, first name, last name, and so on. And of course, each table in SQL should include some have two parameters like primary key and auto counter. In our case, it's a field with the title of ID person and ID test respectively. And each row of this table can consist each separated records of our table. Go ahead. First of all, we have to create our primary table, main one, with a title of passport and auto-counted up field ID person. Let's do it. Select quick tool of tables, and there are a few possibilities. You can create table in a view mode. You can use wizard to create a new table, which can guide you through the steps you need to perform to create new table. But our choice is to create table in design view. It's much more flexible and a little bit complex way, but it's true way because it's provide a huge amount of possibilities to create variety parameters of your table. So this is a choice for beginners, but this is our choice. So first field is must have its ID person. This type should be integer. Let's create another fields. Family name, second name, and so on. Don't forget to save your project, save your table regularly to prevent some damages, and you can specify your table's title, passport, and click OK. But don't forget about your table should have some attributes like primary key. Let's specify it. Right click, primary key, and save your project. and click OK. If we want to increase the space of one separated column, we can use it as usual by snap a border separator, drag it and drop. One of another cons of SQL approach, you have to accept some consideration and use some predefined data types. For example, as you can see, each time we specify a field name, data type will be attached automatically. Each time it's a text varchar as well. So let's specify data types according to requirements. You have to specify correct data types for further purposes. For example, to compare some numerical values, to sort some string data, ascend, descend, and so on. For example, date of born, we can switch to the data type of date, and we can insert some minor modification by following format example, extended menu, and select some data types, just for example English, United Kingdom, and we can modify this mask, just for example day, months, and year in full format like this, and click OK. And don't forget about must-have parameters of table. This field should be primary key, and in addition it should be auto-valued. And click Save, and click close your editor, table editor, and click Yes to save. As you can see, we can check our new created tables with the title of passport in our quick access menu, and we can switch some previews. At present moment there are no records in that table. So as you remember, we was specified that field ID, person, family name, and so on. And you can see, according to the specification must-have feature of table, this field is auto-numbered. Let's create another table with primary key of ID test and ID person. Remember, keep it in mind, ID person and ID person will be attached by relationship one-to-many type. Let's create a table test blood with ID test primary key. Create new table using table design tool. We have ID test, it should be integer, and we have ID person. The same as previous one, it should be integer 2, and we have another fields which represent and results of our blood test. Date of test, hemoglobin level, erythrocyte level, and so on. Let's specify it. And don't forget to attach necessary data types to each separated field name. So let's attach that data types to the appropriate field names, and don't forget to save your project, and attached must have parameters first. And click save, and specify a title of this table, test blood, and click OK. As a result, two tables will be appeared. Don't forget to save your project. And next move, we have to specify relationship between our tables. Navigate to the tools, relationships, and add both of our tables here. Drag it into your preferable place, and attached appropriate fields with the name of ID person. It should be one-to-end interconnection, and we want to update cascades and delete cascades, and click OK. As you can see, relationship one-to-many was created already. Don't forget to save your project, and you can close that window. It's unnecessary for us at present moment. Next move is very important. It's an essential part of the OpenOffice Base interface. Next step, we can create forms. As you can see, we can use wizard or create our form in design view. First one, design view mode. It's very complex, and there are huge amount of benefits provided to you, and there is very useful wizard what can guide you through complete process. Let's create it using wizard. There are few steps we can follow to complete our forms. First one is field selection. As you can see, we can see a relationship between two tables. Let's move our fields to the right side. Let's select all of them. We can use this double arrow right to perform this. And our primary key field, we can switch back. Next move. We want to decide if we need subforms or not. Second order table can be represented as subforms. Yes, we can do it because we want to attach some records about blood tests for each patient, and of course sometimes it's happen the situation when one patient have few records. Click add subform manually, or add subform based on existing relation. We have existing relation and we can select our second order table and click next. At the next move, we have to specify all fields we need, but without ID person. Let's move all of that right and ID person, single ID person back. Click next move, and there are few arrange options provided to you by OpenOffice Base. My preferences is to style a little bit main form and left a subform at the plain spreadsheet. It's very convenient way. Click next. Yes, we want to display our data and we want to have possibilities to edit existing data. We can use this option and click next. We can apply some style. It doesn't matter, just skip this next. And we can make some title for our form. Just, for example, type form. And work with that immediately and click finish. So as you can see, we have automatically created form. Let's insert some data. Just for example, this one. Name 1 for the first record. We have first record and we have name number 1. Second name number 1. And we have insert some data into the subform. Just for example, we can insert first one. Just for example, hemoglobin level of, we have first record, we have hemoglobin level, just for example, 101, erythrocyte level 201, just for example. So we have first record. In the first record we have 1 subrecords. For the first record we have 1 subrecords. Click right arrow to apply our changes for the first record and to edit next one. Let's specify name number 2, second name number 2, and let's consider we have 2 subrecords for the main record number 2. Let's define it. First one, hemoglobin level 102. It's just for example 202. Second one, it's 102, 202, just for example. So as you can see, we have just for example 2 records for the second record, 2 sub-records for the second main record, and click right arrow to apply current changes and to edit next one. Just for example, we can insert record number 3, name number 3, second name number 3, and just for example 3 sub-records, hemoglobin level of 103, erythrocyte level of 203, and the same for the second, 103 and 203, and the same for the third one, 103, 203. So as you can see, we have 3 sub-records for the third main records. Click right arrow 1 extra time to apply previous changes. And you can see we have few records. First one, second one, third one, and that's all. So your data is saved. It's saved automatically. Then you click right arrow and increase auto counter up. Your data was saved automatically. We can close this and we can check some changes. As you can see, few records was added to our primary record. What's next? We can apply some queries. Let's create it. As you can see, we can use plain SQL syntax, or we can use wizard. We can create our query in a query design view mode. And as usual, it's very similar interface for the Microsoft SaaS application. We can insert passport and test blood table, just for example, and click save. As you can see, notification, nothing has been selected. Let's do it. So switch on that switches. It's very necessary. If you plan to use a little bit complex queries, switch on this tool and select a table. Just for example, first one, it's a passport, and select appropriate field from the table passport. Just for example, we wanna use fields in that order. For example, second name. As you can see, it's a little bit bugged because we select appropriate table here. So let's select passport and select appropriate field with the title name. And just for example, we interest in from the passport with interest in date of birth, just for example. And we can use some sub fields from the subform. For example, erythrocyte level, and just for example, hemoglobin level. So as you can see, we can use some aliases, we can select some table, we can apply some sorting techniques, just for example, ascending for the second name. We can make some fields visible or not visible. Just for example, we can left checkboxes or switch it off if need. We can apply some function. There are a lot of functions present here. And we can apply some criteria. If we allocate our criteria in this row, it means we can apply AND statement to it. But we can use OR statement as another row as well. Just for the simple example, we can fetch some result according to the criteria. Just for example, fetch some records with hemoglobin level greater than 101. Just for example. And don't forget to save your changes and make a title of your query. Let's be default and click OK. And you can run your query to fetch some result. So as you can see, the system return some records with the value greater than 101. It's great. If you want to switch back, you can press F4. F4 to toggle between edit mode and result mode. Okay, you can close this and check the presence of the query here, and you can select preview for this. Okay, don't forget to save your project entirely. Good luck, let's create. See you next time.